Welcome. We have studied functions, rates of change, average rate of change, instantaneous rate of change, and connections to secant and tangent lines, slopes, and then we've also talked about different properties of functions, so increasing, decreasing, concavity, maxima, minima, blah blah blah. So we know a bit about functions, right? Before we go into specific function families like polynomial functions and specifically like linear, quadratic stuff, there are a few more things that we need to have awareness of as it relates to functions. So here we go. We're going to look at combining functions. And so combining, when I use that language, I mean taking two functions and adding, subtracting, multiplying, dividing them. Okay. And so here's the notation that we use. You can see it in the definition on the screen. If we're just adding two functions, f of x plus g of x, rather than writing the of x twice, mathematicians have adopted the notation of doing in parentheses f plus g and then of x at the end. So just be aware of that notation, and f minus g, right? It's the same sort of thing. We're just doing subtraction between the two functions, multiplication. Typically when we write multiplication, we actually just leave it out. So it's just fg of x. And then lastly, division. You see we have just f over g. And then we have this included clause where g of x itself, its output can't be 0, because otherwise we're dividing by 0 and bad things happen. All right, so just to get some practice with this, we have some functions here, and we want to find each of these quantities. So m of p plus 1, or m plus p of 1, okay, and then mn of 3, and then there's another one, just p over m of y. So we're going to do this step by step. So m plus p of 1, this just means m of 1, right? And then plus p evaluated at 1. Okay, not a big deal. M of 1 is going to be, 1 squared minus 2 times 1. And then P of 1, right? I'll put that in brackets just so it's clear that that's M of 1. And P of 1 is just going to be 4 times 1. Okay, so then in all I get, what's this come out to? Minus 1 and then plus 4. So in all I get positive 3. Okay, there we go. And then mn of 3. So again, this by definition is m of 3 times n of 3. Okay, again, substitute this in. So I'm going to have, let's see, 3 squared minus 2 times 3 for m of 3. And then n of 3 is going to be 1 over 3 minus 2. Okay, evaluating now, going through and doing the arithmetic. 9 minus 6 is 3 times, and then 1 over 1. Okay, so then I just get 3 for this as well. Isn't that nice? And then lastly, for this one, p over m, I need to maybe just zoom out a little bit. So this is by definition p of y divided by m of y. Okay, and I know that p of y, that was just the function for y divided by m of y was y squared minus 2y. Okay, and actually that's all I'm going to leave it as. I could, well, okay, actually I can reduce. Let's go ahead and reduce. So 4y, and then if I factor the denominator, that would be y minus 2. Okay, and then I could reduce by a y, and I just get 4 over y minus 2. Okay, and there are some restrictions that go along with this before I go to this final step, and a few other things that we'll be aware of in the next video. Okay, but for now we'll just leave it at that. Our last example is looking at graphs. So again, remember, functions do not need to be defined solely in symbols, right? We can define them in symbols, we can define them in words with a description, or by a table, okay, or by a graph or a picture. Okay, so here we go. F of x is in red. I'm just going to label this because otherwise I tend to get confused. And then g of x is in blue. Okay, so I know, okay, got it. Okay, I want to use the graph to find each of the quantities. Okay, fine. This f minus g all of 1 is the same as f of negative 1 plus g of negative 1. Oh, sorry, that should be minus. My bad. Okay, now I'm just going to go to the graph and read this off. So f of minus 1, this minus 1 is the value of x. So I'm going to go to minus 1, go up here. Okay, that's somewhere between 0 and 1. Let's call it, it looks like halfway, so I'm going to call it a half, minus, and then g of minus 1. Okay, g of minus 1, come down here. That looks to be a negative 1 itself. Okay, and so now I'm going to do the arithmetic. Let's see, negative would be a positive, so 1/2 plus 1 fraction, common denominators and all that jazz, if you wish, 3/2. Okay. Next one, fg of 3. This is f of 3 times g of 3. Okay, so again, I'm going to go to 3 for the x coordinate, and then say that my y value, f of 3, that looks to be about 1.5, better known as 3/2. I like improper fractions. What can I say? And then 3, and then for g of x, this is going to be negative 1, so then I end up with negative 3/2. Okay. Last example. Okay, g over f of 0. Okay, this by definition would be g of 0 over f of 0. Okay, g of 0. Okay, what is that? Like 1.75, so 1 3/4. Okay, we're gonna call that 7/4 as a fraction. Okay, f of 0, 0. Uh-oh, that doesn't work, right? Whenever we divide by 0, that's not defined. So we're just gonna say, we can say does not exist, DNE. You can say undefined, anything to communicate to another person that your answer is not possible. Okay, so any one of those are fine. And big takeaway from this video is that we can take two functions, add them, subtract them, multiply them, divide them, right? Go ahead and do it. We have some special notation, and again, the functions can be defined in words, symbols, tables, or in a graph.